In this video, we're going to talk about how to determine if we have a sequence that is converging or not. So our first one is a sub n equals n over n plus 2, which if we were to write out the terms, starting with 1, we would have 1/3, 2 over 4, 3 over 5, 4 over 6, so on and so forth. And the question is to determine whether or not these terms converge to some single number. Well, in order to determine convergence of a sequence, we need to see what happens as n gets infinitely large. So we're actually just calculating a limit. So limit as n goes to infinity of n over n plus 2. We've seen this before. We've used limit notation, and remember as n goes to infinity, we're talking about n behavior. Now, we're doing this in terms of n, but imagine if we used x. So limit as x goes to infinity of x over x plus 2. Because now, if we just look at that part right there, we have a rational function, a polynomial over a polynomial. And think about what we know about polynomials. So these are basically equal. If they have the same degree, which these do, it goes to the ratio of the coefficients of the lead terms, which is 1 over 1. This limit equals 1. If we can calculate the limit, the sequence converges. And in fact, it converges to whatever that limit is. So this sequence definitely converges. Let's look at we're going to look at one more example, and that is if we had something that was said a sub n equals 5. So this sequence is just going to be 5 repeatedly. So if we wanted to find the limit as n goes to infinity of the number 5, well, it's just 5. And so this one converges to 5. So when it's a constant, it's going to converge, and it's going to converge to whatever that number is. So that's how we can determine the convergence of a sequence.